Hi students, welcome to my YouTube channel AM Teachers Tech. This video is on problems on magnitude and phase spectrum. That is your course subject, 5th sem subject DSP, Digital Signal Processing. So this is your lecture 4 video. So the first problem here, if you can see, for a given sequence x of n 0, 1, 2, 3, find the DFT and also plot magnitude and phase spectrum. So first we'll see how to represent an x of n. So if you take an x of n, so if I plot here, okay, so this axis is n. So this one I will represent it at x of n. So this is 0, 0, 1, 2, 3. So this is n when n is equal to 0. Okay, so when n is equal to 1, this is n is equal to 2 and this is n is equal to 3. So what is given? It is given as x of n is equal to 0, 1, 2, 3. So what is this? These are the amplitudes which are been given here. Okay, so 0 means the amplitude is 0, so this is the point. So 1 means, so amplitude is 1. Okay, so 2 means at number n is equal to 2, the amplitude is 2, and at n is equal to 3, the amplitude is 3. So this is the signal x of n, which how we can represent x of n. So this is amplitude 1, this is amplitude 2, and this is amplitude 3. Okay, so this is signal x of n. So we'll start solving this problem. So the first thing what we have to do here is we have to find the DFT. DFT means your discrete Fourier transform. Discrete Fourier transform means we are converting a signal x of n from time domain to frequency domain. Okay, so the equation for that, x of k is equal to summation n is equal to 0 to n minus 1 x. What is the input? Input is x of e to the power of minus j 2 pi by n kn. Okay, so this is the equation where k is equal to 0 comma 1 comma 2 comma dash 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 n minus 1. Now this is the equation. Now this equation I will take it in the form of Tudor factor so that it is easy to calculate. Otherwise for every equation I have to use the Euler's formula. Okay, how much is n here? N is equal to 4. See, in the problem he has not given n is equal to 4, but with the values, these values I can find out that n is equal to 4. Okay, so n is equal to 4 here I am taking up. So now I will substitute in this equation. So this becomes summation n is equal to 0 to 3, as it is n minus 1 x of n. Now this one I will replace with the Tudor factor. So this becomes omega n of kn. Okay, so next what will I do? I will substitute this n is equal to 4, this also. So now summation n is equal to 0 to 3 x of n omega 4 of kn. Okay, now this equation I'm going to expand this equation. So if I expand this equation, this becomes when n is equal to 0, so this becomes x of 0. Okay, so this becomes omega 4 of 0, because k into 0 is 0 only, plus x of 1 when n is equal to 1, so into omega 4 k into 1. Okay, so plus x of 2, so this is omega 4 of k into 2, so plus x of 3, we have 4 values, no, 0 to 3. So next last value is x of 3 omega 4 of k into 3. Okay, now what is x of 0? Now what is x of 0? X of 0 is this one. X of 0 is 0. X of 0 is 0. X of 1 is 1. X of 2 is 2. X of 3 is 3. For that particular n is equal to 0, the amplitude is also 0. For n is equal to 1, the amplitude is also 1. Okay, so that's one we are going to substitute here. So this one I'm going to write it as 0. This one is what? 1. This one is 2 amplitude, and this one is amplitude 3. As x of 0 is 0, so this whole terms become 0. So what I'm going to write it as, left out 3 terms, 1 into omega 4 of k plus 2 into omega 4 of 2k. Okay, so plus 3 of omega 4 of 3k. What is this? This is your x of k. Now we have got x of k. So next what we will do, so this is the equation when we expand our x of n. So we are going to get this equation. In this equation, what we do, the next further step is, further to solve this above equation, what we will do, we will substitute the range of k. So what is the range of k? Range of k is again 0 to n minus 1. So n minus 1 means how much? 3. So it is 0 to 3. Okay. So what we will do, first we will substitute k is equal to 0 in this equation, that is above equation. So this becomes x of 0, so is equal to 1 omega 4 of 0, because k is equal to 0. So plus 2 into omega 4 of 2 into 0 is 0, plus 3 into omega, that is 4 into 3 into 0 is 0. Okay, so how much I'm going to get this? Use this Widal factor for n is equal to 4. So we know this, last video I have told you already. So this one, okay, so what was this? This was your omega 4 of 0. How much it is? 1. This one was your omega 4 of 1. So this was how much? It was minus j. So this is omega 4 of 2. So this is minus 1, opposite of this. Okay, so next value is omega 4 of 3. So this is plus j. Okay, plus j. So opposite of this, this is your imaginary and this is your real. Okay, now from this values I'm going to substitute here. So what I'm going to get here, I'm going to substitute here. So this is 1 into omega 4 of 0 is how much? It is 1. Can you see here? It is 1. So this one I'm going to substitute 1 into 1 plus 2 into 1 plus 3 into 1. So this becomes 1 plus 2 plus 3. So this is equal to 6. Okay, so the next value I'm going to take it as k is equal to 1. Okay, so k is equal to 1. So this becomes x of 1 is equal to, in this equation I'm going to substitute same equation, this it. Okay, so 1 into omega 4 of 1 plus 2 into omega 4 of 2 into 1, that is 2. So plus 3 into omega 4 of 3, because 3 into 1 is 3. So next we are going to substitute the value of Widal factors. So we know that now omega 4 of 1 from the figure, it is how much? It is minus j. Okay, plus 2 into how much is omega 4 of 2? Can you see here? This is the value. So this is into minus 1 plus 3 into j. Okay, so this becomes minus j minus 2 plus 3j. Okay, so this is the real number, so this becomes minus 2. So you have plus 3j and you have minus j, so this becomes plus 2j. So this is your imaginary part. Okay, so the next value, what we will do here, next value we will take it as k is equal to 2. So for the k is equal to 2, again we have to substitute. So x of 2 will be equal to, so it was 1 into omega 4 of 1. So k this becomes 2 plus 2 into omega 4 of 2 into 2. It was 2 into k. So this becomes 4 plus 3 into omega 4 of, in this equation into 2 I have taken. So 3 into 2 is 6. Okay. So what is the value here? 1 into, what is omega? I will write down here. Omega 4 of 0 is 1. Omega 1 is equal to minus j. So this is omega 4 of 2 is equal to minus 1. So omega 4 of 3 is equal to j. Okay, so 2 means how much here? I'm going to substitute here is minus 1 plus 2 into omega 4. See, I told you Tudel factor has periodic property. Last class we have done that. So this will be again repeated. So this will be equal to omega 4 of 4. Okay, so this will be equal to omega 4 of 5. So this will be equal to omega 4 of 6. And this is equal to omega 4 of 7. So omega 4 of 4 is how much here? It is 1. So I'm going to substitute here 1 plus 3 into omega 6. 4 of 4 means it is equal to omega 4 of 2. So because of that, this becomes minus 1 here. Okay, so this is minus 1 plus 2 and minus 3. So this becomes 2 minus 4. So this becomes minus 2. So this is the value of when k is equal to 2. 3. Next value we are going to take it as k is equal to 3. So this is x of 1 into omega 4 of 3. We had k here. Okay, so k is equal to 3 means, so this becomes 3 plus 2 into omega 4 of 3 2s are, that is 6. Okay, you had a 2k, so this becomes 6 plus 3 into omega 4 of 9. 3 3s are 9. If you want, you can see this equation. So here we have an equation. So 3, k is equal to 3 means, so this becomes 3 into 3, this becomes 9. So 2 into 3, this becomes 6, so this becomes 3. So 3, 6 and 9. Okay, so you can see here. So now this is, what is 3, 1, this is 1 into omega 3, how much here? Omega 3, can you see here? This one, so this is j. 2 into omega 6, how much is it? Minus 1. Okay, plus 3 into omega 9 is what here? So this is 8, this one is 8, and this one is omega 4 of 9. Okay, so omega 4 of 9 is how much? It is minus j. So this will be equal to minus j. Okay, so this is j minus 2 minus 3j. So this becomes minus 2 minus 2j. Okay, now we will write down the equations. What we have got, the value x of k, we have got first value of how much we got? We got it as 6 comma, we got minus 2 plus 2j. Okay, so next value we got it as minus 2, and the last value we got to this one, we have the last value here only, so it is minus 2 minus 2j. Okay, now for this we have to calculate the magnitude and phase. So the formula to calculate the magnitude and phase is z is equal to, for the complex number, if the number is in this form, plus j b, so this is what real number and this is imaginary number, then the magnitude of z will be equal to, I can find out the magnitude, so this will be equal to square root of a square plus b square. Okay, so this is how we calculate the magnitude. And angle, how do we calculate? Alpha is equal to tan inverse of b by a. So you can use this formula and you have to calculate it here. Okay, so I can use the calculator also, and or I can use the formula also, or in the exam at least one time you please write down the formula, and at least one equation you show it in the with respect to the formula. Okay, so the first value, what we will do, first value we'll try to find out. So 6 means, how do I write 6 plus 0? Okay, so that means z is equal to root of 6 square plus 0. So this becomes root of 6 square. So this is 6. Okay, so the first value, magnitude value, x of k, so like this I will write. So this will be equal to, the first value is 6. Okay, and the second value I can take it as alpha, that is tan inverse, how much? B is what here? B is 0. So 0 divided by 6. See, we know that anything divided by tan 0 divided by 6 is 0 only. So the angle, what I am going to get it here, 0. So magnitude k, so angle is equal to 0. Okay, otherwise also you can use the calculators. All of you can use the calculators. In the calculator, what you can do, go to the mode. If you see, you have to go to the mode. I'm going to write down here, all of you. So mode, press 3 times, you get a degree option there. So when we get the degree option there, in that you have 1. So click it on 1 in the degree mode. So what you have to do, you have to set it to degree mode. I hope everyone knows how to set to the degree mode in the calculator. Then click on shift plus. Okay, when you click on shift plus, so in the calculator it's going to show you a POL, that is polar. Okay, so in this polar, what we have to substitute, what are the values here? First value is what we have got, it is 6. So 6 I have to substitute, comma 0, because imaginary part is 0 here. Can you see here? Imaginary part is 0 here. So you have only 6 value. You don't have an imaginary part. You have only real part. So you have to substitute 0. So both the values you have to give. If you have both the values, you have to give it both the values. If you don't have, then which value you don't have, that value you have to substitute as 0. Okay, so when you press on this, and then you have to give the value, and then you have to press it on equal. So when you give press it on equal, for this value it will show the magnitude as 6, and then for the angle you have to click it on alpha. You have at the left side, upper side of your calculator, alpha. Then you have to press it on tan, and then you have to press it on equal. So at that time it's going to show you 0. Okay, so the angle is 0. Okay, so you have got the 0. Okay, so the next value is, so how you have to substitute in the calculator here, you have to substitute pole for the second value, pole, it is -2 and 2, like this you have to substitute. All other procedure is same. So when you substitute, you are going to get here 2.8, and angle you are going to get it as 135. It will show 135 means it is 3 pi by 4. Okay, otherwise if you want, you can write it in the bracket also, 135. Okay, so next value is what? -2 you have. So -2 means, how do you substitute? You have to substitute pole, then -2, and then 0. Okay, and then it is equal. Okay, if you substitute, you are going to get what is that, magnitude as 2, and angle you are going to get it as 180. So 180, how I am going to write? I am going to write it as pi. Okay, so for the next value you have to substitute pole, or you can use this formula also. It is very easy to use this formula also. Okay, so pole, I'm going to show one more value with that also if you want. So pole, so it is -2 comma -2. Okay, so if you substitute this, and if you check it in the calculator, you are going to get this value, last value as 2.8, and this value you are going to get it as again -135. So -135 means this will be 3 pi by 4. Okay, so these are the values here. So if you want this value, if you want, how do you have to write for using the formula? So this is equal to root of -2 whole square plus -2 whole square. So this becomes minus into minus, so this becomes how much? 4 plus minus into minus, 2 into 2, so this becomes +4 again. So root of this one, so this one becomes root 8. So this is nothing but 2 root 2 or it is equal to 2.8. Okay, same way you have to substitute for the tan angle also. If you substitute, you are going to get 100 minus 135. That is nothing but same thing. Okay, so the next is, or I can write it like this, both the equations, or I can even write it like this. So this one I can write it as magnitude 6, angle is 0. This way also I can write down 2.8, that is angle is how much, 33 pi by 4, comma, again I can write 2, magnitude is how much here, it is pi, so I can write down like this. Third one, it is fourth one, that is 2.8, and how much is the magnitude, it is minus 3 pi by 4. Okay, so these are the values we have got, magnitude and phase, magnitude and angle we have got. So next we'll plot the figure for this. This is 0, 1, 2 and 3. So this is axis is, okay, so this is magnitude. Okay, so this is how do we represent, x of k of magnitude, and this is k. Okay, so the first, when n k is equal to 0, how much we have got, magnitude. So this is some way I am going to plot 6. Okay, so next, when k is equal to 1, how much is the magnitude, magnitude is 2.8. Okay, when n is equal to when k is equal to 2, how much is the magnitude, magnitude is 2. So magnitude is 2. Okay, so when k is equal to 3, again how much we got the magnitude, we got the magnitude as, so this is, I hope you know, this is when k is equal to 0, when k is equal to 1. Okay, when k is equal to, because it is into frequency domain, so we are going to use the axis as k. In frequency domain we represent axis as k. Okay, so this is k is equal to 2 and this is k is equal to 3. Okay, so this is how we plot for the magnitude. Same way we can plot it for angle. Okay, so axis is again what, it is k only. So this is phase spectrum. So how do I represent this? This is x of k. Okay, like this angle is represented as this. So this is when k is equal to 0, k is equal to 1, k is equal to 2 and k is equal to 3. If you want, you can just put a line here, and at the same line you can draw at the same line. So when k is equal to 0, what is the angle, angle is 0. So I'm going to represent it as like this. So when k is equal to 1, what is the angle, angle is something, angle is 135. Okay, so this is, I'm going to represent it as 3 pi by 4. When k is equal to 0, the angle is how much, the angle is 180. So 180 is more than what is that, 135. So it will be something somewhere here. This is what, pi, and when k is equal to 3, it is down here because it is into minus. So this is how much, minus 3 pi by. I hope you have understood this problem. We'll go for the next problem. Okay, now next we will do problem number 2. Now if you see this problem here, it's for a given sequence x of n, amplitude, that is value, that is nothing but your amplitude is how much, 2, for the range of 0 to n minus 2. So n he has given in the problem only. So how much is the n? N, it is a capital N is 4, capital N is equal to 4. Okay, in this you have to calculate DFT, that is discrete Fourier transform, that is you have to convert from time domain to frequency domain as we have done in the first problem, and also you have to calculate the magnitude and phase spectrum and also to plot them. Okay, so first we will find the range of this. We will write the equation for x of n. So x of n is how much, this is x of n. So how much is the amplitude? Amplitude should be 2. So what is given here, it is from 0 to n minus 2. So it is n minus 2 means how much, 4 minus, it is 2, that means 2. That is the range starts, the range of n now it becomes 0 to, that is, it should be greater than or equal to 0. You have a equal to, then that's why we have to start from 0, and less than or equal to 2. That means the range will be till 2. Okay, so that is the n is equal to 0, 1, 2. So what will be the range? The range will, what will be the amplitude? or you can call it as what will be the value, it will be 2. Okay, so n is equal to 0. What is the value? It is 2. Again n is equal to 1. What is the value? Again 2. And n is equal to 2. Again what is the value? Value is 2 only. But it is, as it is a 4-point DFT. So what is the last value? So last value I will do 0 padding. Okay, so 0 padding I am going to do. So these are the 4 value of x of n for n is equal to 0, n is equal to 1, n is equal to 2, and n is equal to 3. Okay, so now with this value we have to start our doing calculations. That is, we have to first find out the DFT. So for DFT, what is the equation? Before that, writing the equation, I'll plot this figure. So x of n, this is n, axis is what? N. So what is this one? So this is your x of n. Okay, x of n, discrete signal. So this is 0, 1, 2, 3. So 3 values we have. So what is the amplitude, or what is the value for this is at 0. The amplitude, this one I will write it as, this axis also I will write it as 1, 2, 3. Okay, so this side what we are writing the amplitude, that is values, and this side it is the value of n. Okay, so when it is 0, what is the value? Or I can call it as amplitude also. So it is 2. Okay, at n is equal to 1, what is the amplitude? It is again 2. At n is equal to 2, what is the amplitude? It is nothing but 2. So how much is the amplitude? It is 2. And at n is equal to 3, what is the amplitude? Amplitude is 0. Okay, so this is the signal x of n. This is how we are going to represent the signal x of n. Okay, so now we'll write the equation for DFT. So the equation for DFT is x of k is equal to, as I'm converting from time domain to frequency domain, so output should be the frequency domain. So the output signal should be in x of k. So k is in frequency domain. Okay, summation n is equal to 0 to n minus 1. Okay, so what is the input? Input signal is x of n. On this we are doing discrete Fourier transform into e to the power of minus j 2 pi by n kn. Okay, so we have already defined the range of n. Okay, now we will define the range of k. So the range of k is equal to k is equal to 0, 1, dash 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 n minus 1. So usually in this subject the range of k and n, usually it will be same. If it is a different, then they will specify in the problem. If they are not specifying in the problem, then you can take the range of k and n as same. Okay, so here, and one more thing what you have to remember, if it is here n x of n, then this range will be in the n only. If the input is x of k here, then you have to use the range of k is equal to 0 to n minus 1. Okay, fine. So this one, next step what I am going to do, this value I am going to replace with the Tweedale factor. Okay, summation n is equal to 0 to n minus 1. Okay, x of n. Okay, omega n k. So next I am going to substitute the range of n. So the range of n is what? N is equal to 0 to, can I write 3 here? Because it is 4 minus 1. 4 minus 1 it is 3. So this becomes x of n. So this one I am going to write it as, and this n I am going to replace by 4, because n is equal to 4. This is kn. Okay, so the next step what will I do? I am going to expand this equation. So if I expand this equation, I am going to get, so n is equal to x of 0. When n is equal to 0, it becomes x of n into omega 4 of k into 0 plus, next is when n is equal to 1. Okay, so this becomes x of 1 into omega 4 of k into n, because it becomes k into 1. Okay, plus when n is equal to 2, so x of 2 into omega 4 of k into 2. Okay, so the last value when n is equal to 3 plus n is equal to 3, so this becomes x of 3 into omega 4 of k into 3. Okay, fine. So what is this x of 0? We know what is x of n. X of n is how much? It is 2, 2, 2, 0. From this equation, we know that this is x of 0, this is x of 1, this is x of 2, and this one is how much? This is x of 3. Okay, so this is x of 0. So we know that. Okay, so this value I'm going to substitute. How much is this? This becomes 2 amplitude, and this also will become 2. This is also 2. Okay, and this is 0. So the last what value I'm going to remove, because anything multiplied by 0 is 0. Okay, so I'm going to rewrite the equation again. So the equation becomes here x of k is equal to 2 into omega 4 of 0, because k into 0 is 0, plus 2 into 4 k, because k into 1 is k, plus 2 into omega 4 of 2k. Okay, so this equation I will take it as equation 1. Okay, now we have got this equation after substituting the value of n is equal to 0 to 3. Now next, to solve this problem, what we have to do, we have to substitute. We know that k, the range of k also, what is the range of k? So the range of k is 0 to n minus 1. Okay, so k is what? So k will be also equal to 0 to 3. Now what I'm going to do, I'm going to substitute the value of k. First value I'm going to take, that is k is equal to 0, as we have done in the previous problem. So k is equal to 0, I'm going to substitute first value. So this becomes x of 0. Okay, so this becomes 2 into omega 4 of 0 only, plus 2 into omega 4 of 0, k is equal to 0, I have substitute, then plus 2 into omega 4 of 2 into 0, it is 0. So we know that what is the value of omega 4 of 0? Omega 4 of 0 is 1. So what I'm going to do, I'm going to substitute into 1 plus 2 into 1 plus how much? 2 into 1. Okay, so this value is going to be what? 2 plus 2 plus 2, so this becomes 6. X of 0 is 6. Okay, so the next value we are going to go here. So this is when k is equal to 1. Next value I have taken. So this becomes x of 1. So this is equal to, in equation 1, so the value of k, wherever I have a k value, see, can you see here, wherever I have a k value, now I am going to substitute k is equal to 1. So that's why this becomes 2 into omega 4 of 0 plus 2 into omega 4 of 1. Here, can you see this one? In this equation I'm substituting. Okay, plus 2 into omega 4, 2 into k, it is 2. I hope we know this values here, Twiddle factor values. So what is omega 4 of 0, omega 4 of 1, omega 4 of 2, and last value is what? Omega 4 of 3. So this is equal to what? Omega 4 of 1 is 1. Okay, this one is minus j, minus 1, and the last value is what? J. Okay, so we know that Twiddle factor is periodic in nature. Okay, that's why what will happen, after n value it's going to repeat itself. That means after 4 values it's going to repeat itself. So this becomes omega 4 of 4. So this becomes omega 4 of 5. So this becomes omega 4 of 6, and this becomes omega 4 of 7. Okay, now this one I'm going to substitute here. So what is omega 4 of 0? It is 1. So 2 into 1 plus what is omega 4 of 1? That is minus j. So 2 into minus j plus 2 into what is 4 of omega square, that is 2. So this is minus 1. What is 4 of omega 4 of 2? It is minus 1. So this becomes 2 minus 2j and minus 2. So this minus 2 and plus 2 will get cancelled. So what you are going to get? Minus 2j. So value of x of 1 is minus j. Okay, so the next value is 2. Okay, so this becomes x of 2 is equal to, in this equation 1 I'm going to substitute. Okay, so this becomes 2 of omega 4 of 0 plus 2 into omega 4 of 2. I'm substituting in equation 1, plus 2 into omega 4 of, that is 2 into 2, this becomes 4. So this, can you see, 2 into 2, this becomes 4. Okay, because the value of k is 2. So this becomes 2 into 1 plus 2 into, how much is this one? Omega 4 of 2, it is minus 1. Okay, plus 2 into omega 4 of 1 is how much? It is 1. So this becomes 2 minus 2 plus 2. So this one and this one will get cancelled. So what I'm going to get, sorry. So which one is, so this one and this one will get cancelled. So you are going to get the value of this one as 2. Okay, so the next value is, when k is equal to 3. So the equation becomes, now you have to substitute k is equal to 3 in equation 1. So this becomes x of 3. So this is equal to 2 into omega 4 of 0 plus 2 into omega 4 of 3, because k is equal to 3, plus 2 into omega 4 of 6. So this becomes, see here, 2 into 3, so this becomes 6. Now I'm going to substitute here from this above two del factors. So this becomes 2 into 1 plus 2 into, how much? It is j. Above only the values are here. This value I have substituted, plus 2 into omega. What is this? Omega 4 of 6, it is minus 1. So this is minus 1. So this becomes 2 plus 2j minus, okay. So this 2 and this 2 will get cancelled. So what I'm going to get? I'm going to get it as 2j. Okay. So these are the 4 values for x of k. Okay. So we'll write the values first here, what we have got for x of k. Okay. So first value what we have got it as, we'll write the values for x of k. So the first value when x is equal to 0, it's here only. Can you see? And we have got is 6. So 6 I'm going to write here. So the next value is what? Minus 2j we have got. Third value we got it as 2. And the last value we have got it as 2j. Okay, so these are the value of x of k. This is when k is equal to 0, this is k is equal to 1, this is k is equal to 2, and this is k is equal to 3. Now only we have just find out, and this is the values in values of k, and this is into frequency domain. Okay, so we have converted from time domain to frequency domain by using the equation DFT, that is x of k equation. Okay, so next is what we have to find out, the magnitude and phase spectrum here. Last problem also we have found out. So first I will write down the equations to calculate the magnitude and phase spectrum. So if the equation is a plus jb, I hope everyone knows this is your real number, real value, and if there is a j, then we are calling it as an imaginary value. Okay, so this is your complex number. If it is in the form, we are calling it a complex number. Okay, so this is in a rectangular form. Okay, now to convert, what we can do, we have to convert from rectangular form to polar form through the calculator, or I can use the formula, that is magnitude formula. Z magnitude is equal to root of a square plus b square. I can do through this calculations, and alpha I can calculate as tan inverse of b by a. Okay, b by a. Yeah, this is the formula, or I can use the calculator also. Okay, so the first value, we will start with the first x of k magnitude. Okay, so this is what, so the first value is 6, that means 6 plus, it is z is equal to 6 plus 0, because imaginary part is 0. So the equation becomes root of 6 square plus 0 square. So this becomes root of 6 square. So this is how much? It is 6. So the magnitude is 6 only. And angle, I will show one value. So this is tan inverse of 0 by 6. So this is 0 only. Anything tan inverse of 0 by 6, that is any value is 0 only. Okay, I will show you in the calculator also. So the value is how much here? It is 6, first value of magnitude, and the angle angle is how much? It is 0. Okay, the first value. For the second value, we are going to use the calculator. First, what you have to do in the calculator, you have to be in degree mode. I hope everyone knows how to go to the degree mode. Go to the degree mode, that is, you have to press in the calculator mode and then press 3 times. There you can see degree, radian and degree, radian, that is degree they have been showing as 1 and radian they are showing as 2. So click it on 1, then you are in the okay. So after that you have to shift it, click on shift, then plus sign, plus shift sign plus, and then you are going to get like this POL, that is from rectangular to polar. So you're converting the data into polar. So for what is A is equal to 6, what is B is equal to 0. So I'm going to substitute here 6 and 0 like this, and then I'm clicking on equal. So when I click on equal, so what I'm going to get, magnitude I'm going to get 6 only, and then I have to click it on alpha, and then I have to click it on tan, and then equal. So then I'm going to get 0 for the first value. So for the second value, what I have to do, I have to click it on pole. Once you get a pole here, so first what you have to do, you have to click it on shift, then plus, then you're going to get pole. So first value will be 0 because A is 0, and second value is what? -2. So if you click and then you get it amplitude 2, and angle you're going to get it as, for angle procedure, same procedure you have to use. So that is alpha, and then you have to click it on tan, then equal. So when you click on equal, you are going, so what you are going to get there in the display, so -90. So -90, how we will write? So minus pi by 2. Same way, next value, so you have to give pole, POL 2, 0, and last value you have to give it as POL 0, 2. Okay, so if you give this and if you press it on equal, so you're going to get amplitude as 2, and angle you're going to get it as 0. Again here, if you say equal, then you are going to get amplitude 2. Then you have to click it on alpha, then tan, so if you click it on equal, then the angle you're going to get it as 0. Same way here, when you say equal, click it on equal, then amplitude, again you are going to get it as 2 here, and after this you have to click it on alpha, then you click it on tan, then you can get, you can see you are getting as plus 90. So 90. Okay, so here it is 2, here it is pi by 2. Okay, so these are the 4 values of magnitude and angle. You can write like this, or you can write the values, write it as like this. So 6, angle is how much? 0, 2, angle is how much? Minus pi by 2. Okay, again magnitude is how much? 2, angle is 0, and the last value 2, and angle is pi by 2. I can write like this also. In some textbook they have given like this. Don't get confused, you can write like this also, and you can write like this also. For this, now we are going to plot the graph, magnitude and phase. Axis is what? K. Now we are into frequency domain, so the axis is K. If the signal is x of n, then the axis will be n. 0, same here also, 0, 1. So our magnitude, how do we write? We write it as x of k, like this 2 lines, and phase spectrum we are going to write like this, angle, or you can call it as angle also. Okay, so 6. So 6 at n is equal to 0, what is the magnitude? Magnitude is 6. Somewhere here it is 6. Okay, and angle is how much? It is 0. So I'll just put a cross mark here. Then at k is equal to 1, magnitude is 2. You can just make it 1, 2, 3, 6, and you can draw it neatly. Okay, so the amplitude is how much here? 2, and the angle is what? Minus pi by 2. So minus means it will come down. So this one, minus pi by 2. Okay, again magnitude at k is equal to 2 is 2. So this is the line, so this is 2. And what is the angle? Angle is 0. So I put it like this, that is on the 0 axis line. Okay, when k is equal to 3, so again magnitude is how much? Magnitude is 2 only. So this one like this, and how much is the angle? Angle is pi by 2. So pi by 2. So this is your magnitude. Okay, this completes your problem. See, you can do, we have used in the calculated degree and I have shown you. If you want, you can use radian also. If you are using the radian, so there we have selected as 1, degree 1. So you have to select degree 2 and you have to do the calculation. Okay, same way, same procedure. Okay, so in degree, in radian, what happens, it will give you something in 1.2, 1.8. You can write like that only. But if you want in the terms of pi, that is pi by 2, pi for 180, we write it as pi. Or if you want 3 pi by 2, then again you have to convert it into pi. So that's why I have shown you in the radians, degree only. Okay, fine. So I'll show you one verification method to verify whatever the value we have got here. So this value, what we have got here, is correct or what. Okay, because so these values should be correct. Only these values are correct, then only you are going to get whole marks. So this problem will be 8 marks. So first I will show you the simple verification that whatever the values you have got is correct. This is called your matrix method. For that verification method for that, x of k, I will write it as x of 0, x of 1, x of 2, x of 3. We have 4 values now, from 0 to how much? 3. This is x of k. So this is equal to, what is the values here? Matrix value I'm going to write. So next video I'm going to show this matrix, how we are getting this. Okay, so now you can just take down this. So this will be like this, matrix value. So this is minus j, minus 1, again j. So this is minus 1, 1, and minus j. This is 1. No, this is j. This is minus 1, and this is minus j. Okay. So what is the input? Input is x of 0, x of 1, x of 2, and x of 3. So that is, we have taken as 2, 2, 2, and 0. This is our input. Okay. So this is matrix, what is that, n into 1. So this is n into n, and this is again vector n into 1. Okay, so first what I have to do, I have to multiply this row and this column. Okay, this becomes 2 plus 2 plus 2 plus 0. So 1 into 2 it is 2, 1 into 2 it is 2, 1 into 2 it is 2, 1 into 0 it is 0. Okay, so the next I will take this row, second row, and a column is same. Okay, so this becomes 1 into 2, 2. So the next value is 2 into how much it is, 2 into minus j. So this becomes minus 2j. Next value is minus 2, next value is plus 0. Okay, so the third value is this row and the same column. So this becomes 2, minus 2, plus 2, plus 0. Okay, and the last value, that is last row, this one. So this is 2 plus 2j, okay, minus 2 and plus 0. Close this. If I add this, so I'm going to get it 6. So this one and this one is going to get cancelled. So this becomes minus 2j. And the next value is what? So this and this will get cancelled. So you are going to get how much? 2. So again this value and this value will get cancelled. So how much you are going to get it as? 2j. So what we have got, now you can see the values. What we have got it there and here, you can compare. So it is the same values. So this how within 2 or 3 seconds you can check that whatever the values you have got after using the formula of DFT is correct or what. Okay, J. Okay, so it is same. Okay, so we have done today 2 problems. So thanks for watching for the video. Please subscribe, share and comment so that I can make more videos. Please subscribe. Okay.